Hey fifth graders, welcome to Miss Mills Math Lab. This is going to be a short video going over our skill for the week. It will be posted in Schoology under your math page, and it's a great video to go back and watch if you need extra help with a skill or to review for a test, so that you don't have to watch the entire Zoom class. And I will probably post a couple of these a week for you to go back and watch if you need them. So we're going to go ahead and jump into the lesson, and we are working on long division this week. Our standard for the week is 6.ns.2, and the 6 just stands for 6th grade. NS stands for number systems, and the 2 tells me that I'm working on the second standard under the number systems content area. And our standard says that students will fluently divide multi-digit whole numbers using the standard algorithm. So fluently, when we do something fluently, it just means that we're doing it automatically, that we've learned the steps in the process so well that those steps just come automatically. We don't have to stop and think about them. And we're going to be using the standard algorithm. Guys, algorithm is just a fancy teacher word because you know teachers like to use big words to mean method. So we're using the standard method or traditional method of long division. I want to go ahead and point out that there's always more than one way to solve a problem. And probably over the last couple of years, you've learned several strategies to divide numbers. You've learned things like repeated subtraction, partial quotients, and those strategies are great when you're working with smaller numbers. But the larger your numbers get, the longer it would take you to use those strategies to get to an answer. Your standard algorithm is usually going to be your fastest way to get to an answer. So that's what we want to make sure that we're focusing on now, is making sure that you're able to use that standard method and use it fluently. We know that in math, long division is the method that's used for dividing large numbers into groups or parts. And the method of long division helps us solve division problems by breaking larger numbers into a sequence of smaller, easier steps in order to get to a final answer. Before we jump into solving long division problems, I want to make sure that you know the parts of a division problem. So with every division problem, we have 3 main parts that you need to be aware of. We have the dividend, which is the number being divided. We have the divisor, which is the amount of times that we are dividing that big number. And then we also have the quotient. So for example, if you had the problem 32,597 divided by 15 equals 2,173, remainder 2, then 32,597 would be your dividend. 15, the amount of groups that you're dividing that into, would be your divisor. And then your answer, 2,173 remainder 2, would be your quotient. Typically, we do not write division problems like this. We have to rewrite them using the box or house method to solve them. So I just wanted to give you another example and make sure you understood that the dividend usually goes inside of our box or house. It is the number that is being divided. Our divisor goes outside of our box or house. It is the number of groups that we are breaking this dividend into. And our quotient or answer goes on top of our house. The standard algorithm, or the traditional long division method, is just a way of breaking a larger division problem into a series of smaller steps that makes that problem easier to solve. The key to doing long division is to think about our division problem digit by digit. The nice thing about long division is that once you know the procedure, it makes dividing large numbers pretty easy. There are 5 basic steps in the process of long division, and those steps are to divide, multiply, subtract, bring down, repeat, or list your remainder. Once you memorize the 5 steps in the process of division, it makes long division go pretty smoothly. And one of the silly ways that I've always taught my kids to remember those steps is to use the sentence, does McDonald's sell burgers raw? And the does stands for divide. McDonald's helps me remember to multiply. Sell helps me remember to subtract. Burgers, bring down. And then raw would be to repeat or list my remainder. So let's look at this problem as an example. I have 8,413 and I want to divide that into 7 groups. And just to review for our vocabulary words, that we know 8,413 is going to be our dividend. It is the number being divided. And 7 is going to be our divisor. It is the number of groups that we are dividing into. If I think about my basic facts for 7, not even just my basic facts, but the facts that I can easily do in my head, I know that 7 times 12 is going to be the largest number that's on my multiplication table. And that doesn't get me anywhere close to 8,413. That's 84. That's not anywhere close to that. Even if I do 7 times 100, that gives me 700. That's still not anywhere close to 8,413. Now, if I did 7 times 1,000, that's going to get me closer, but that's still not anywhere close to 8,413. So trying to divide this large number into 7 groups in one step is going to be very difficult. That's not something that I can do in my head. But if I use the process of long division, which says that I can break this large number into a series of smaller steps and divide digit by digit, then it makes my problem a little less overwhelming and a lot easier to solve. So let's do that. Let's take it digit by digit. I'm going to start with the first digit, which is 8, and I'm going to ask myself, can 8 be divided into 7 groups? It can. Now, it's not going to divide evenly, but that's okay. If I took 8 and I broke it into 7 groups, I would put 1 in each group. So I divided. Then I'm going to multiply my divisor times the number in my quotient. So 7 times 1 would give me 7. And the next step is to subtract. 8 minus 7 would give me 1. And it tells me to bring down the next digit in my problem. Now, because I'm dividing digit by digit, I can only bring down 1 digit at a time. So I'm going to bring down my 4. It's going to team up with my 1 to make a larger remainder so that I can continue to divide. All right, so I have 14 and I want to divide 14 into 7 groups. All right, so I'm going to divide. Well, I know that 7 times 2 is exactly 14. So if I divide 14 into 7 groups, I would put 2 in each group. And then I'm going to multiply. 7 times 2 is exactly 14. I'm going to subtract, which leaves me 0. And the next step in my process tells me to bring down my 1. Now remember, I can only bring down 1 digit at a time. And if you notice, I'm being very careful to keep my numbers lined up. It's very important that when we're doing long division that we are keeping our numbers organized, because a lot of times I see mistakes with students when they don't line their numbers up and their writing is not organized. They subtract the wrong thing and they start making mistakes. So we want to make sure that we keep our writing organized and neat and our numbers lined up. All right, so I want to divide 1 into 7 groups. And you might say, but Miss Mills, I can't divide 1 into 7 groups. And you can't. But we can't skip this step. So we can't just leave this blank. We have to put something here. So we're going to put a 0. and then we're going to multiply. 7 times 0 is 0. I'm going to subtract, which leaves me with 1, and then I'll bring down my 3. All right, the 3 teams up with a 1 so that I can keep dividing. 13 divided into 7 groups. We just said that 14 divided into 7 groups is 2. So 13 divided into 7 groups would be 1. I can't go over 13, and 14 would be over, so I have to go back down to 1. 7 times 1 is 7. I subtract, and it leaves me with a remainder of 6. Now, because here I don't have any other digits to bring down, for now, we're going to put 6 as our remainder. Later on, we'll see that there's something that we can do with that remainder that would help us to keep dividing, but for now, we're going to just put 6 as our remainder, and we're going to stop here. So my quotient would be 1,201 remainder 6, and that would be the answer to this problem. Let's look at another example. Here I have my dividend 3,822, and I want to divide it into 21 groups. And even though 21 is a 2-digit divisor, my steps in my process are going to remain the same. I'm still going to divide, multiply, subtract, bring down, and then I will repeat those steps or list my remainder. Now, because 21 is not a number that I have typically memorized my facts for, I have 2 choices. I can either write out my facts for 21, which some people will do, 21 times 1, 21 times 2, and they will list those facts over here to the side in their margin. 21 times 3, you write that correctly. 21 times 3 would give me 63, and I could keep going, and they would list them all the way to 9. I'm not going to list out my facts. I'm going to use estimation to help me solve my problem, and I will walk you through that as we find our answer. All right, so I'm still going to go digit by digit just like I did in the last problem. And I'm going to start with the first digit in my dividend, which is 3. And I'm going to ask myself, can 3 be divided into 21 groups? And the answer is no. So since 3 cannot be divided into 21 groups, I'm going to put a 0 here. And I'm going to combine 3 and 8 together to make a bigger number. All right, and I'm going to ask myself, can 38 be divided into 21 groups? And the answer is yes, 38 is bigger than 21, so it can be divided into 21 groups. Here's where I'm going to use estimation. 21 and 38 are not numbers that are easy to work with in my head. But if I round them to multiples of 10, 21 is close to 20, and 38 is close to 40, then that makes them easier to work with in my head. And I can easily look at this and say, okay, 20 would go into 40 2 times. 40 is larger than 38. So I bet if I multiply 21 times 2, I'm going to get an answer that is larger than 38. 21 times 2 is 42. And 42 is larger than 38. So I can't use 21 times 2 here because I can't have a number larger than 38. I wouldn't be able to subtract. So I'm going to have to take a step back, and I'm going to do 21 times 1, which gives me 21. So I put my 1 here. I've divided. I'm going to multiply. 21 times 1 is 21, and I'm going to subtract. Notice I'm keeping my numbers lined up by place value position. 8 minus 1 is 7, and 3 minus 2 is 1. All right, so I have divided, I've multiplied, I've now subtracted. the next step in my process is to bring down my 2 to make my remainder larger so that I can keep dividing. And because I can divide here, then I'm going to repeat. So again, I need to take 172, which is not a number that's easy to work with in my head, and I need to divide it into 21 groups. All right, I'm going to round 172 to 170, and I'm going to round 21 to 20. And I'm going to ask myself, how many times will 2 go into 17? Well, 2 times 8 is 16. So I'm going to try. All right, so I'm going to try 21 times 8 and see what I get. All right, 8 times 1 is 8, and 8 times 2 is 16. That's 168. 168 is smaller than 172, so I am going to try dividing by 8. And we just said that 21 times 8 is 168. I'm going to keep my numbers lined up. I'm going to subtract. I do have to do a little bit of regrouping here. 12 minus 8 is 4. 6 minus 6 is 0. 1 minus 1 is 0. So I am going to look at my problem. I still have another digit up here, my 2. And the next step in my process would be to bring down that 2 and to continue to divide. All right, so if I bring down the 2 to make my remainder larger, I have 42. And we just said not long ago that 21 times 2 is exactly 42. I'm going to subtract, which leaves me with 0. So my quotient is 182 with no remainder. Okay guys, so here is another example. In this example, we have 1,778, which is our dividend, divided by 54. I'm going to use the same steps. I'm going to divide, I'm going to multiply, I'm going to subtract, I'm going to bring down, and then I'm going to repeat the process for each digit in my dividend, and I will list my remainder at the end if there is one. All right, 54 is not a number that I typically memorize my facts for. So I'm going to have to either write my facts out for 54 over here in the margin, or I'm going to have to use a little bit of estimation. I'm still going to try to divide digit by digit, and I'm going to start with the first digit in my dividend. 1 cannot be divided into 54 because it is smaller than 54. So I'm going to put a 0 here, and I'm going to combine the first 2 digits together. And I'm going to ask myself, can 17 be divided by 54? And again, the answer is no, because 17 is still smaller than 54. So I'm going to put a 0 here, and I'm going to move on and combine my first 3 digits together. So because I'm having to use more digits here, it is a little bit more challenging, but it's still not as hard as trying to divide the entire number all at once. So here's where my estimation is going to come in. Over to the side of my margin, I'm looking at the numbers 54 and 177. And neither of those are very easy to work with. So I'm going to round to multiples of 10 so that they are easier to work with. I'm going to round 54 to 50. And I'm going to round 177 to 180. Okay, and I'm going to ask myself, how many times will 5 go into 18? 5 will go into 18 3 times. So if that's the case, then 50 would go into 180 about 3 times. So I'm going to check my math over here. I'm going to try that. I'm going to say, okay, 54 times 3, and I'm going to see what I get. And remember, I need to get a number smaller than 177, equal to or smaller. 3 times 4 is 12. 3 times 5 is 15. Plus 1 would be 16, which would give me 162. That's pretty close to 177. If I added 54 more to that, I would go over, so I know that 54 times 3 is as large as I can possibly multiply. So I'm going to do 54 times 3, which we just said was 162. And I'm going to subtract, which leaves me with 15. The next step in my process is to bring down. So I am going to bring down the next digit, which is 8. And that gives me a total of 158. We just said that 54 times 3 was 162, and that's larger than 158, so I'm going to take a step back and I'm going to try 54 times 2, which gives me 108. Check my math, that's right. So I'm going to put my 2 here, I'm going to put my 108 here, I'm going to subtract, and I have a remainder of 50. And you might say, well, 50 is a really big remainder, but one way to check, as long as your remainder is smaller than your divisor, then you should be okay here. So my quotient would be 32 remainder 50. Okay, guys, here's one more example. I have 5,355, and I want to divide it into 27 groups. I'm going to use the same steps as I have in the past. I'm going to divide, multiply, subtract, bring down, and then I will repeat those steps or list my remainder. I'm going to divide digit by digit, so I'll start with the first digit in my dividend, which is 5, and I'll ask myself, can 5 be divided into 27 groups? Well, the answer is no, so I'm going to put a 0 here to be my placeholder, and I'm going to combine the first 2 digits to make a bigger number. All right, can 53 be divided into 27 groups? The answer is yes. 53 is larger than 27. So it can be divided into 27 groups. I just need to know how many times. I'm going to use estimation to help me decide that. I'm going to round both of these numbers to multiples of 10 to make them easier to work with, to figure out where to start. So 53 would round to 50, and 27 would round to 30. Then I'm going to ask myself, how many times will 3 go into 27? And the answer is 1. So I'm going to come down here and I'm going to say, okay, 27 times 1, of course, is 27. 27 times 2, just to check. I always want to go one above just to check. 7 times 2 is 14. 2 times 2 is 4, plus 1 would give me 54. And even though 54 is closer to 53 than 27 is, I cannot use a number that is larger than what's already there. So I cannot use 27 times 2 because 54 is larger than 53. I'm going to have to use 27 times 1. So I'm going to put my 1 here. I'm going to do 27. I'm going to subtract. There's going to be a little bit of regrouping. 13 minus 7 is 6. 4 minus 2 is 2. I've divided, I've multiplied, I've subtracted. The next step is to bring down my 5, which is good because 26 could not be divided into 27 groups, but 265, that 5 makes a larger remainder, which means that I can continue to divide. All right, I'm going to come over to my margin. I need to figure out how many times 27 will go into 265. So I'm going to write 265 here, and I'm going to write 27 here. And even though those look like large numbers, and it looks like I might need a calculator to figure that out, I don't. I'm going to use estimation, which will help me figure out how many times 27 will go into 265. So I'm going to round 265 to 270, which is easier to work with in my head. And of course, 27 rounds to 30. And then I'm going to ask myself, how many times will 3 go into 27? Well, 3 times 9 is 27. So I'm going to try 27 times 9. 7 times 9 is 63. 2 times 9 is 18, plus 6 would be 24, which gives me 243. So I'm going to use 27 times 9. Now, I wouldn't even check 27 times 10 because you can't put 2 digits above one number or above in one place value position, so I couldn't use 10 anyway. So 9 is the biggest number I can possibly use. All right, so 27 times 9 would be 243. I'm going to subtract. That gives me a remainder of 22. I have to bring my 5 down here to join, which gives me 225. And I'm going to come over in the margin and do a little estimation to see what I'm going to use in my quotient to get me close to 225. I'm trying to get close to 225. Well, my thing is not erasing. All right, so 225, I would round it to 230, and then 27 would round to 30. Okay, and I'm going to ask myself, how many times will 3 go into 23? Well, 3 times 8 is 24. That's too much. 3 times 7 is 21, so I'm going to try 27 times 7 and see what I get. So 27 times 7. 7 times 7 is 49. 7 times 2 is 14. Plus 4 would be 18, which would be 189. That's kind of small. Let me see what 27 times 8 is, just out of curiosity. 8 times 7 is 56. 8 times 2 is 16, which would be 216. So in this case, I'm glad I checked up a step because that gave me 216, which is closer to 225. All right. Let me just check that again. 16, 17, 18, 19, 20, 21. Yep. 216. I always like to double check myself. All right, I'm going to have to do a little bit of regrouping here. 15 minus 6 would give me 9, and 1 minus 1 is 0, so I have a remainder of 9. So my quotient here, my answer would be 198, remainder 9. All right, guys, this is the last problem in our lesson today. I'm going to ask you to pause the video here, try to solve the problem on your own, and then when you have finished, come back and check your answer to see if you got the same thing I did. I will work the steps out, and you can, if you did not get it right, check your steps and see where maybe you made any mistakes, and then we will come back in just a second and discuss your answer. All right, guys, you should have gotten an answer of 59, remainder 8. 36 times 5 gave me 180, When I subtracted, it left me with 33. I had to bring down my 2, which left me with a remainder of 332. 36 times 9 was 324. When I subtracted, I got a remainder of 8. One way to go back and check your answer is to use the inverse of division, or the opposite of division, which is multiplication. We would multiply this divisor of 36 times our quotient of 59. 9 times 6 would give me 54. I'm going to carry my 5. 9 times 3 is 27. Plus 5 would be 32. I'm going to put down my 0. 5 times 6 is 30. 5 times 3 would be 15. Plus 3 more would be 18. When I add, I get 4, 2, I get 2,124, which my quotient is 2,132, but don't forget you have a remainder that you have to add in here, plus 8, which gives me my remainder, which leaves me with an answer of 2,132, which is what my dividend was. So I know my answer is correct. I checked it with my multiplication. All right, guys. This is the last slide that I have for you today. This is just an example of a problem with the steps written out. I would like for you to take a minute, pause the video, and write this down in your notes so that you have it. Tomorrow when we come back together, we will do some more practice with long division, and I'm going to show you an alternative method to the traditional standard algorithm that might help some of you that are having a hard time staying organized. I hope this gave you some good practice with long division, and we will see you in Math Lab again tomorrow.